12.1c is on independent and dependent events. So, two events are independent if the occurrence of one has no effect on the occurrence of the other. So, for example, if a coin is tossed twice, the outcome of the first toss has no effect on the outcome of the second toss. Right? It's the same coin, it's the same probability either way. So, in order to calculate the probability of an independent event, we take the probability of event A and we multiply it by the probability of event B. And we say independent events are with replacement. Dependent events are two events are dependent if the occurrence of one does affect the occurrence of the other. So for example, if you're drawing a king from a deck of cards and then you draw an ace without replacing the king. So dependent events are without replacement, which means that for the second event, the original conditions have changed somehow. So to calculate the probability of dependent events, we take the probability of A and multiply it by the conditional probability of event B. Conditional probability is the probability that event B will occur given that A has already occurred. Okay, so the probability B will occur given that A has already occurred. So let's look at a couple of examples using our new vocabulary to really figure out what all of this is talking about. So letter D, identify if the following are independent or dependent. A jar contains red and blue marbles. You randomly choose a marble from the jar and you do not replace it. So you keep that marble. Then you randomly choose another marble. So we want to find the probability that event A, the first marble you choose is red, and event B, the second marble you choose is blue. Okay, well, this is going to be dependent. These events are dependent on each other because you are taking a marble out. You do not replace your original marble. So for example, say for the first probability you had 20 total marbles, then the second time when you're trying to find the probability of picking your blue marble out, you have a different number of total outcomes. You only have 19 total outcomes that are possible. So if you take something and you can't replace it, you can't reset it to those original conditions, that is dependent. Let's look at another example. So when you're looking at these situations, you always need to ask yourself, hey, is this independent or is this dependent? So as a part of a board game, you need to spin the spinner, which is divided into equal parts. You want to find the probability that both events A and B will occur. Okay. Well, if you think about a spinner, okay, if I spin this spinner once, is that going to affect it? The first time I spin it, is that going to change anything for the second time I spin it, or the third or the fourth? And the answer is no, right? It's always going to be the same spinner. It's always going to have these same different options when we're spinning it. So this is independent. This is independent because the conditions when we start off each event are always identical. They're always the same. So we want to find the probability that you get 25 on your first spin. Well, there are two 25s on this spinner and 8 total sections. So the probability of event A would be 2 over 8. And again, we're going to multiply. When we're talking about independent and dependent, we're multiplying. We're going to multiply it by the probability of event B. So the probability that you get 50, well, there's only one 50, so that'd be 1 out of 8. This would be, we multiply this together, we'd get 2 over 64, which simplifies to a probability of 1 out of 32. Let's look at a couple more examples. So number 2, a bowl contains 36 green grapes and 14 purple grapes. You randomly choose a grape, you eat it, and then randomly choose another one. So find the probability that both events A and B will occur. So if you're going to eat if you're going to eat the grape, then can you replace it? Can you return the bowl of grapes to the original condition? The answer is you can't, right? This is without replacement, and that is how we know that this is a dependent situation. Okay, event B depends on event A, dependent. All right, so we are going to find the probability of A and we're going to multiply it by the conditional probability of event B. Well, what's the probability that the first grape is green? Well, we have, again, 36 green grapes, 14 purple grapes, which leaves us with a total of 50 total grapes, 50 total grapes. So the probability that the first grape is green is 36 out of 52. Okay. Well, then we want the probability that the second grape is green. But in event A, we ate one green grape. So we lost one of our green grapes. So we only have 35 green grapes out of a total of 49 grapes at this point. Okay, and that's our conditional probability. The condition is that we took out that grape, we adjusted our numbers, we adjusted our probability based on the fact that we ate that first grape. We'd multiply these together, and when you simplify, you should get 18 out of 35 is the probability of picking a green grape, eating it, and then picking another green grape. This would be a good time to pause and see if you can set up number 3. So number 3, a drawer contains 12 white socks and 6 black socks, so that's 18 total socks. You randomly choose one sock, you do not replace it, and then you randomly choose another sock. What's the probability that both socks are white? Well, you do not replace it, so since you don't replace the sock, that means this is dependent. Okay, so we're going to find the probability of a white sock, and then the probability, multiply it by the probability of getting a second white sock. Okay, after we already took one out. So there are 12 white socks, so our original probability would be 12 out of 18 for choosing a white sock. And then if we choose another white sock, well, now we only have 11 out of 17 socks to choose from. When we multiply this together, it gives us a probability of 22 out of 51. Number 4, suppose you flip a coin twice. What's the probability you get tails on the first flip and tails on the second flip? Well, if you flip a coin, it doesn't matter how many times you flip it, you're always going to have either heads or tails. So this is independent probability. Doesn't matter how many times you flip that coin, your original conditions are always going to stay the same. So the probability of flipping tails is half, times the probability of flipping tails again is half. So you have a 1/4 probability. Last but not least, number 5, you randomly select 2 cards from a standard deck of 52. What's the probability that the first card is a heart and the second card is the first card is not a heart and the second card is a heart? So the first card is not a heart, the second card is a heart, and we have 2 different situations. So let's look at letter A first. So you want to find the probability that you replace the first card before selecting the second. So if you replace the first card, that's going to be independent for our first option. And then letter B, you do not replace it, so that's our dependent situation. So we want to see if what changes between our independent and dependent situations. Well, all the cards that are not hearts, that's 39 cards that are not hearts and 13 cards that are hearts. So the probability of getting a card that's not a heart is 39 out of 52 times the probability of getting a card that is a heart. If we put the card back, well, we'd still have 52 cards to choose from. Okay, and out of those 52, 13 are hearts. We can simplify this to 3/4 times 1/4, which would give us an overall probability of 3/16. So that's our probability, our independent probability in this situation. What about if we do not replace that first card? Well, the original probability stays the same. We have 39 cards that are not hearts out of 52 cards total. But since we took one out and we did not replace it, when we're calculating the probability of event B, we only have 51 cards to choose from. But since the first card we picked out was not a heart, we have 13 cards in there that are hearts. When we multiply these together and simplify, we should have a final probability of 13 out of 68. So when we're talking about independent and dependent events, always ask yourself, is it independent or dependent? And then multiply your probabilities together based on that independent or dependence.